everyone. Today I'm going to explain about exponents and exponential function. So without wasting time, let's get started. So, exponent can be any number, positive, negative, real, even complex, rational or irrational. Let's take an example to know what exponent actually is. For example, 2 into 2 into 2 into again 2 and again 2, it gives 2 to the power 5. So, in this case, this 5 is our exponent. And this 2 becomes our base. Basically, there are two types of exponent. One is a rational exponent. And the next one is irrational exponent. So, before explaining it, let me make you clear by giving one example for rational exponent. Let's take 16 to the power 2 by 3. So let us assume this 2 by 3 as n by m. So there's basically a rule in exponent that if the power raised on the number in the form of n by m, if this n is not equals to 0, then we can say that this number with the raised exponent becomes the rational exponent. I repeat, if the exponent n by m, where m is not equals to 0, if this satisfies the condition, then the number becomes the rational exponent. I hope this is clear. Now, let's move to the next part, which is irrational exponents. So, what is irrational exponent? If anyone is there's a lot of confusion about irrational exponent. So, the number that is raised by an irrational, the number which is raised by an irrational number is irrational exponent. For example, if you don't know what irrational number is, you'll never know what irrational exponent is. Let's take an example. But before that, let me make you clear what irrational number is. Irrational number is never-ending numbers. For example, pi, root 2, these are very famous irrational numbers. We can say these numbers do not have repeating patterns. So, that means I think it is already clear what is irrational exponent. The number which is raised by irrational number or which has the exponent as irrational number is the irrational exponent. So, we can also take 2 to the power root 2 as our example for irrational exponent. That was all about exponents. Now, let's move to the second part, which is the rules of the exponents. Okay, so let me write some numbers and then explain you the rule. For example, let's take 3 by 2 whole to the power cube. So, this basically becomes 3 to the power cube by 2 to the power cube, which is 27 to the power 8. Yeah, normally we do this, which gives our first formula x by y whole to the power a is equals to x to the power a by y to the power a. Okay. Let me write some other number on this side. Okay, let's take an example. 2 to the power 4 into 2 to the power cube. What does this mean? Do you remember when I wrote the example of exponent? by writing 2 into 2 into 2, I wrote 2 to the power 5. So normally we can do it in the same way here. This is like 2 into 2 into 2 into 2, and this is like 2 into 2 into 2 3 times. So when we count all this, it becomes 2 to the power 7. But it looks very childish to do this, right? So if we apply the next formula here, we can easily find out the values. For example, x to the power a into x to the power b gives x to the power a plus b. This is the formula. So if we apply in this, we can easily get 2 to the power 4 into 2 to the power 3. This is our question, which would be 2 to the power 4 plus 3, which gives 2 to the power 7. And we don't have to do this. Alright. And now, let's move to the next part. As we got from this formula, as we already got this formula, we can write like 2 to the power 2 into 2 to the power minus 1 equals to 2 to the power 1. Is it? Yeah. So now, this can be written as 2 to the power minus 1 equals to 2 to the power 1 divided by 2 to the power square. From this line, when we take this power 2 down, it becomes like this. So, 2 to the power 1 minus 1 becomes 2 to the power, 2 divided by 4, which is basically 1 by 2. Can you see something here? I obviously can see. That is the new formula. X to the power minus 1 is equals to 1 by x. Yeah. Yeah, that might be our basically number 3. Now, let's move to the next part. So, we already got that formula. And now, we can also take, for example, let's take 5 to the power minus 2, okay? If we take this, we can write 5 to the power minus 1 into 5 to the power minus 1 is equals to 1 divided by 5 into 1 divided by 5, which will become 1 divided by 5 squared. So, that is basically 1 divided by 5 squared. So, yeah, from here also we can get something. We can see something that 5x to the power minus a becomes 1 divided by x to the power a, which is similar to that kind of formula, but we need to think about the powers and not make mistakes when we do actual problems. This can also be written in some other way, that is x to the power a by x to the power minus b. Let's assume there is some number add down x to the power a by x to the power b. So, we know that from this all, that x to the power b, when it comes up, becomes minus x to the power minus b. From our first formula, which we derived before, we can write here as x to the power a. But here is minus, remember, so x to the power a minus b, which is our next formula. Yes, we have come up with so many formulas, I even forgot the numbers. Anyway, so yeah, till this we came with so many formulas, deriving and also relating one formula to the other. But now let me take you to another formula which is very interesting. Okay. Let's take one number. For example, 12 to the power 0. I took this number as an example, okay? So, how can we write this into the second line, or how can we work with this number? Let me think. Yeah, we can write it as 5 to the power 12 to the power 5 by 12 to the power 5, right? Okay, I just skipped one step, that is 12 to the power 5 minus 5. So 12 to the power 0 can be written as 12 to the power 5 minus 5. So from all the formulas that we derived before this minus 5, we can write it down like this, right? Or let's expand it to another line. That is 12 to the power 5 into 12 to the power minus 5. This compiles all the other formulas that we derived before and proved before and found before. So if you watch closely, 12 to the power 0 is equals to 12 to the power minus 5, 5 minus 5. We broke it as 12 to the power 5 into 12 to the power minus 5. So it goes like this, which becomes 1. Yeah, and it seems we got another formula. That is x to the power 0 is always 1. Yeah. Okay. Now let's go to another number game. Let's take for example 2 to the power square whole cube. Okay. So we took a new number to experiment maybe, I don't know. Okay, we took this number. What can we do with this number? As I did it at the very beginning while explaining or giving the example of exponent, we can break it in the same way. Let's go. 2 to the power square, it means that 2 square should be multiplied 3 times. That means 2 square into 2 square into 2 square. So from the formulas that we derived, we can write it as 2 to the power 2 plus 2 plus 2 gives 2 to the power 6. So what can we say from this formula is if 2 to the power, if x to the power a whole b is given, maybe we can take as an example, if x to the power ab is given, we can write it as x to the power a into b. Okay, we derived another formula from this question. I hope it is clear. But let me make it clear on one part. If this parenthesis is not given, then we cannot directly multiply a and b. Let me give you an example. X, what I mean to say is that x a parenthesis b is absolutely not equal to x to the power ab. Because in this question, for example, if there is x to the power square, we need to do the square of this first and then do the cube for this part. I hope it is clear. Now, let's go to exponential function. So what is exponential function actually is? Okay, now to explain about exponential function, a function which has the exponent as x can be defined as exponential function. For example, fx is equals to 2 to the power x. Let's take the example as this. Okay, let's write y equals to 2 to the power x. So what I meant before was function, exponential function is a function where x has to be in the exponent. There might be a question in your mind, like is it exponential function? It's absolutely not exponential function. It becomes a polynomial. you have to be very careful that x should always be in the exponent to become an exponential function. If x is not in the power, in the exponent and is in the base, it is absolutely not exponential function. So you have to be very, very careful in this part. So let's try to figure out the graph of exponential function. How might it look like? This is x and y. Okay. By taking this function, y is equals to 2 to the power x, we will try to find out how does exponential function look like. So let's try to derive the table. So if x becomes 1, y becomes 2. If x becomes 2, y becomes 4. If x becomes 3, y becomes 8. If x becomes 4, y becomes 16. So let's take some small numbers. If x becomes 0, y becomes 1. If x becomes minus 1, y becomes 1 by 2. If x becomes minus 2, 1 by 4. Okay. I think all these points is enough to give us the actual figure of our exponential function. So let's get started. As it is chalk, I may not have the exact, but I will try to graph as much as possible to numbers. Okay, so 1 takes 2, 2 takes 4, and 3 takes 8. So let's assume that 16 is above somewhere in the line. So 0 takes 1, and for minus 1, it becomes somewhere here, somewhere here, somewhere here, and here for 1.4. So yeah, this is basically exponential function. Well, we try to graph it. Yeah, this is kind of infinity, and this is our exponential function. Y is equals to 2 to the power x. So now let me make you clear, very, very clear, that this point, how much you try to plot when you add other numbers like minus 3, minus 4 in x bar, the y is never ever gonna be negative. The y will never touch and become 0. It is always small, either small or smaller number, but it never becomes 0, which is called asymptote, which means it might be very less, very, very, very less, but it never ever becomes 0. It stays near the 0 line, but it never becomes 0. That was all about exponential function. You might have some question, like if the function is y is equals to 2 to the power x minus 3, won't it become 0? And won't the values become negative? Of course it becomes negative. But what I mean to say is that while plotting this, in this case, this side value never becomes negative. But for this function, let me plot somewhere. For this function, our graph will be the same, but it will shift 3 times below. So in this case, some of the values may become negative, but the asymptote, it will remain the same. That will never ever become 0. The asymptote will remain the same. There will be some asymptote. Okay, that was all about exponents and exponential function. I hope you understood a lot about exponents and exponential function. Maybe some of your questions might have answered. Yeah, that was all about it. I hope you all enjoyed. You got important information. I hope that was quite helpful. Thank you very much.